Hello everyone, I am Kalpana in the Department of ADS at Shriram Engineering College. Today we will explore support vector machines, one of the most powerful and widely used algorithms in machine learning. Support vector machines are particularly effective for classification tasks and have strong theoretical foundations in optimization and geometry. Support vector machine is a supervised learning algorithm. It can be used for both classification and regression, but it is most famous for classification. The key idea is to find a decision boundary that separates classes with the maximum margin. The idea of support vector machine is to find a hyperplane that separates data points of different classes. Unlike other classifiers, SVM chooses the hyperplane that maximizes the margin, the distance between the boundary and the nearest data points. These nearest points are called support vectors and they are critical in defining the model. Mathematically, the hyperplane is defined as W into x plus b equal to 0. The optimization problem is to maximize the margin, which is 2 divided by modulus of W. At the same time, we impose constraints so that all training data points are correctly classified. This leads to a convex optimization problem, which guarantees a unique solution. Then we go to linear versus non-linear support vector machine. When data is linearly separable, support vector machine works directly with the hyperplane, but real-world data is often non-linear. To handle this, support vector machine uses the kernel trick, which maps data into higher dimensions where it becomes separable. Popular kernels include polynomial radial basis function, which denoted as RBF, and sigmoid. The kernel trick is one of the most elegant ideas in machine learning. Instead of explicitly computing transformations, kernels allows us to calculate dot products in higher dimensional spaces efficiently. For example, points arranged in concentric circles cannot be separated in two-dimensional, but after kernel mapping, they become linearly separable in higher dimensions. Next, advantages of support vector machine. Support vector machines are powerful because they work well even in high dimensional spaces. They are effective when classes are separable and can be robust to overfitting if we choose the right kernel and regularization parameters. This makes them suitable for text classification, bioinformatics, and image recognition. Next, going to limitations. However, SVMs are not perfect. They can be computationally expensive for very large data sets. Since training involves solving a quadratic optimization problem, the choice of kernel is critical. Wrong kernel selection can lead to poor performance. Also, support vector machines may struggle with noisy data where classes overlap significantly. To summarize, support vector machine is a maximum margin classifier that relies on support vectors to define the decision boundary. With the kernel trick, it can handle nonlinear data effectively. While it is powerful and theoretically sound, it can be computationally heavy and sensitive to kernel choice. Understanding support vector machine gives us insight into both geometry and optimization in machine learning. Thank you.